Hi, Dmitry here with One for the Robot, and today we'll be talking about motors, actuators and different ways to make your robot move. Let's start with the type of motors that we'll be using. This is important to understand in order to scale our robot right and choose what's actually available, because for someone who's relatively new to the field and want to do some home project, you need to go not from what's possible but what you have access to, and kind of analyze what's publicly available, what is cheap, is it actually usable, etc, etc. So you have to do a little bit of a different research, and you need to understand how things are working because of that. Let's start with DC motor. DC motor is something that basically working using magnets. So you have one magnet, another magnet. There is a special side when they don't want to meet. This effect can be used to move the motor, because when you use electric magnets, they can be turned on and off. So you can think about this way. So this is a magnet and this is a magnet. So when we turn the light on, they will be moving, right? So as a result, we will have this sort of situation. When we turn on electricity, it turns, right? Then we turn on electricity on two other magnets, it turns again, and then we continue to do it very fast, and we have the motor running. This is very efficient approach, power efficient, but there is a problem, because it doesn't really work on a low speed, so it needs to turn very fast in order to work. If we want to use it, we need to make some sort of a gear or convert power from something that spins very fast to something that spins slower. So you can very easily imagine it. If you have the small cog and you have the large cog, then when the large cog makes just one turn, small cog will make quite a bit more. This way we will kind of lose the power, so we'll have to make sure that motor is actually powerful enough, etc, etc. And this is not so hard, because all motors have their parameters and you just need to research what they mean. They have a torque, etc, etc. So the torque pretty much what we need right here, because it's basically how capable your motor of actually turning under load. And since we are going to do something 1 foot tall, I don't see any problems with actuators, because they don't have to be too powerful. Another type of motors that we will be using is servo motor. It's a little bit of a different thing, because we will not be using servo motors that can go indefinitely, and there is a good reason behind it. If you remember this DC motor, it just spins forever, and there is no way to know what its exact position, because it just spins. But when we are working with joints like elbow or hand, you can clearly imagine how we need to know what is our current position, because we need to know where our arm is in order to move it to the positions that we want to. So we need some sort of precision out there, and servo motors are cool from this perspective. They have this limited, they usually have a stopper, they usually can be modified so they go indefinitely, but you will be losing this option to get your position right. Now I started to research it after I understood what sort of thing there are. There are other options, but they are either expensive or draw more power, so tough. And I would prefer to stick to the easy parts. So I analyzed what I need, and I realized that the total will be 12 different motors and actuators for the robot, but we'll start with something smaller. Now let's see how these motors can be stacked up in order to make a robot. So we have the body of the robot, and on the bottom of the body we will have two servos with wheels attached. On top of the body we have a little bit of construction. We have servo attached to servo in order to make the shoulder. How we are doing it: first servo just moves hands up and down, so you can imagine hands a stick and you just move it up and down, right? but we also want left and right. So on the servo that moves up and down, we move another one that can move left and right. And now we can move left, right, but we can also move servo that moves our left and right, and it will turn. As a result, we have arms. In the end, let's discuss a little bit more about the robot and how I plan to scale it. So beginning will be basically this body and wheels with DC motors and with something temporary just so it's not fall. And the reason why it can move, the DC motors can be turned on and off separately. So if only one wheel goes, it just turns. It will be a little bit hard to make the precision mapping when it moves like this, but we are not making a race car or whatever. It's just a house robot that needs to move around the house, and this will be perfectly fine. And when the legs will be added and the elbows will be added, still the wheels will be on the elbows, right? So the robot will raise his arms when he's on this wheel mode and raise his legs up, so it will be some sort of a bucket. As a result, we will be able to more or less securely move around objects with this robot, so it's already useful. But I want to keep this opportunity so it's stand up, or maybe well, not maybe, it's and my goal is to create the system where a user can actually train the robot to stand up, so maybe save some versions of the model during the reinforcement learning part of it, or just make it completely reinforcement learning so user actually had to train it or it won't work at all, or just save your model in some states and just upload it by using like the playtime or some other metrics. We will be thinking how exactly to interact, but it's something fun. And now when I actually shopped and researched the materials and actuators, and I almost have my bucket list complete of what I need, I'm still researching on controllers, etc., because when you have such big amount of moving things, I mean, you need to power them, you need to connect them to some sort of a system where they can be centralized, others ROS nodes, etc., etc., so you can actually control it efficiently. This will be another challenge and completely another day. So at least I'm glad that things are moving ahead. Have a good night. And blow them and down.